This is an ABC podcast.
Hello and welcome to this week's Health Report with me, Norman Swan. Today, how twins can help us understand the impact of COVID-19. The World Bank and the International Monetary Fund are coming to the rescue of low-income countries with coronavirus, but will it be a rescue or a disaster? An update on where the virus came from and how looking at its genes could help Australia control the pandemic once we relax the lockdown, and how COVID-19 could keep on coming back for years, even after we think we've conquered it. Christine Tedianto of Harvard University School of Public Health co-authored a paper in the journal Science last week which tried to predict the medium-term future post-pandemic.
There's two things here. I think the first is that because this virus can have such mild manifestations, people can get the disease and either have very mild symptoms or even be asymptomatic. This virus could still circulate at low levels and then reappear again, potentially due to increases in transmissibility from seasonal factors, for example. And the reason why we might see it come back again after many years is dependent on the duration of immunity that infection confers. And that's still very much an open question. There are a lot of people trying to understand the immunity to this virus. They're trying to understand, once you get it, are you protected? And if you are protected, for how long? What we do is we use antibodies from blood samples from people to try to understand this question. And if we get blood samples from the same people over time, we'll be able to understand how long immunity lasts. What we see for the coronavirus that circulate seasonally, so these are coronaviruses that are endemic. They are common causes of common cold symptoms. What we see with these viruses is that the understanding seems to be that immunity to these viruses is on the order of a year, maybe a little bit more or less. And these viruses cause peaks every winter. And so if this novel coronavirus also has immunity on the order of a year or so, then we might expect the same thing. We might expect these kinds of recurrent wintertime outbreaks annually. If immunity to the new coronavirus is longer than a year, 2 years, 5 years, then we might expect to see peaks that are on the order of that duration. So biannual, even more sporadic than that.
So you could think that COVID-19 has gone completely, but it suddenly reappears in 2024. Christine Tedianto also has views on whether, as some are alleging, COVID-19 modelling has created unnecessary panic.
One thing that tends to be unfortunate about public health measures is if they're successful at controlling disease, they look like an overreaction because we don't see the terrible consequences that were projected because the measures were effective. So I think that in terms of this novel coronavirus pandemic, the best thing that we could do at the time, the best thing that we knew to do in order to not overwhelm healthcare systems was to kind of take this whole hog approach where we did everything we could to slow the spread of the disease. And I think that we saw that be effective in many places where we're now seeing a slowdown of cases. I think that that was the correct step to take at the time. And I think what's important to convey is that we can't go straight back to business as usual.
Because the problem is that if COVID-19 comes back, it could be much worse than the first round.
We're going to need to slowly and carefully lift these measures because the virus doesn't have memory. It doesn't remember that. All that it knows is that there are still many people that are susceptible in the population. And as we lift the measures, those people are susceptible to getting the infection. I think the second and third waves could be worse than the first if we are unprepared for them. So if we responded the first time, once we saw that this was spreading all over the world, we took measures. But taking these kinds of social distancing measures really requires strong political and social will. If we, the second time around, begin to see an increase in cases, but we lack the ability to put in place the appropriate measures, second and third waves can be just as bad, if not worse than the first.
Christine Tedianto of Harvard School of Public Health. And you're listening to RN's Health Report with me, Norman Swan. As the pandemic continues, we've become less concerned with the origins of the virus and more with how we'll control it. But understanding the virus's family tree, a field of science called phylogenetics, could help us prevent future pandemics. And as lockdowns come and go, understanding whether cases of the virus are related might help us track COVID-19 clusters, which is vital if we're to keep the numbers of new cases as low as possible. Dr. James Hadfield is a New Zealand-based phylogeneticist who works with the Bedford Lab in Seattle. I spoke with him earlier. James, thank you very much for joining us on the Health Report again.
You're very welcome. Nice to talk to you.
I think it's only a month since we last spoke. What have you found in that last month? What's evolved? What's the pattern that you're seeing?
When we were last talking to each other a month ago, we were really interested in answering these questions about how did it get from country to country. At that time, we were talking about a couple of hundred genomes which had been made available, which was a really good effort at that time. But now, I think we're up to about 10,000 genomes released.
10,000?
10,000. It's an amazing effort from all of the groups around the world, not only technically but also politically, to release this data publicly. And so our questions have changed a bit. A lot of the world is on lockdown, as you know from Australia and I do from New Zealand. And so the questions have pivoted slightly towards localized questions about different countries, or even more fine-grained than that, different regions. How is the virus moving in those regions? So we're doing a lot of work now trying to help different labs around the world, different sequencing labs, different public health institutions, to run their own data focused on the samples that they're collecting in their area.
When you look at the evolution of the virus, what's it telling you about that fine-grained analysis about where it came from and how it's spreading internally and the mutations and so on and the evolution?
It's good to revisit what we mentioned last time, the first rule of phylogenetics, which we should always keep in the back of our minds, that if it looks like the virus is behaving differently, 99% of the time it's because of epidemiology. So we are seeing a lot of mutations. We expect that every 2 to 3 transmissions, so person A to person B to person C to person D, we would get one change in the genome. So we are collecting changes in the genome and they're helping us track it.
But what you're saying is there are more footprints in the sand rather than functional. So if, in other words, Italy or New York State look more aggressive, you're saying that's because the public health measures have allowed it to be more aggressive and spread rather than being a peculiar virus to those countries.
Yes, I think it's always tempting to try and look for a genomic reason, but more often than not, it's due to perhaps the public health response, perhaps chance, bad luck. Lots of many other things could be causing the differences that we're seeing.
There's been a paper recently looking at the way this has evolved, not your lab, and it suggests that there's 3 main types of this virus, A, B and C, which roughly correspond to geographic locations. Does your phylogenetics from these 10,000 samples suggest the same thing?
There's been a number of scientists around the world raise some concerns about the way that the science had been done and the impact on the results that they wrote about. And the second line is the interpretation, or rather the over-interpretation by the media. And this has led to some pretty bold headlines, things like no proof that COVID-19 originated in Wuhan, or variant of the virus which infected Britain wasn't found in China. And I think a lot of these aren't actually necessarily backed up by the statements that they made in the paper, and they're causing, I think, a lot of trouble in the understanding or the interpretation of what's happening.
Well, let's go back to the origins, because in the end, at some point in this story, we will have to go back to the beginning, because it's how pandemics start and preventing, hopefully, pandemics from starting in the future. You're still confident in the Hubei province, Wuhan origins of this?
All evidence so far is supportive of a single jump from an animal reservoir that's still a little bit up for grabs into the human population in and around Wuhan. And I think it's really important that we tell that story, because there's a lot of other stories going on in the media with various interests. And I think the paper that we were just alluding to is being used by some to sort of push a different agenda.
So in other words, you're saying that there are moves afoot to de-emphasize China as the origin here, whether that's political or whatever.
Yeah, I think there's lots of different interest groups, but I think the genetics still overwhelmingly points to a single introduction early on in sort of late November, early December in Wuhan.
And still from a horseshoe bat?
That's up for grabs. That's very academically interesting. There was a paper that came out recently from Eddie Holmes's group, who's a professor at the University of Sydney, sort of showing that a similarly related virus collected from a pangolin was very
Chinese
similar.
anteater, the supposed animal, yeah.
Yeah, which my understanding is quite often trafficked in China. And they sequenced there a while ago a virus that in a very small part of the genome is the closest relative to SARS-CoV-2. But for the rest of the genome, it's more closely related to a virus that has been sampled from a bat. So I think we're still unclear exactly what animal reservoir it came from. It's probable that it was from a bat and then to an intermediary and then to humans. But what exactly that intermediary is, whether it was pangolins, is still, I think, rather speculative.
Now, a reasonably well-substantiated story emerged in the last few days. I think it was the Washington Post that put it out there, which is that if you go back a year, 18 months, there were alarm bells being run by US scientists who'd seen a lab in Wuhan. They thought that it wasn't being properly managed in terms of biosecurity, and they were doing gain-of-function testing in the lab. In other words, they were taking bat viruses and trying to see how you actually got mutations to make them more nasty, and that they were worried that this could be a source of escape. And this is documented quite some time ago, long before the pandemic emerged. I mean, I've spoken to biosecurity experts here who say you can't eliminate the possibility that this is an accidental escape from a lab. What's your view, having looked at the phylogenetics?
Yeah, I think it's always going to be hard to prove a negative, but again, the evidence seems overwhelming that this virus did come from either a bat or an intermediary from a bat, and there's a number of signs that would lead us away from the engineered type hypothesis,
such as?
Including the fact that there are a number of common strains that you would use in the lab, and this is not one of them.
In other words, so in other words, if you were going to do a gain-of-function test, this is not the virus that you would have used necessarily.
It would be a very unexpected choice to use one that has not been seen anywhere else before. You've got to remember that this virus, while it's closely related to one from a bat, we're talking about 50 years of evolution, if not longer.
And this is what you said last time, is that you can find bats in the 20th century that you've taken viruses from that seem to be the origins of this virus over a long period of time.
Yes, and my understanding is there is a lot of research being done on coronavirus strains in labs. However, we know, although those strains have been published, we know what the genetic makeup of it is, and so if it were the case that this was an escape from one of them, the genetics would show very clearly that it is closely related to one of those strains.
And just finally, Australia is moving towards slowly releasing the lockdown, social distancing and so on, but it's going to continue doing testing. And assuming that happens, how, if at all, does the research you're doing into phylogenetics help a country like Australia move forward in keeping this pandemic in check?
Yeah, so I think the researchers in Australia are doing a wonderful job. I think from last count, there was over 1,000 genomes shared publicly from universities and sequencing labs in Australia. And so as the lockdowns come and go, sequencing of these genomes, testing and then sequencing and understanding the relationships will help us track down those remaining clusters of community transmission and understand better the low-level onward transmission that's really important to stamp out if we are to eradicate the disease.
I'm not sure I understand. In other words, they pick up a virus, let's say in June, the genetics might tell them that that was a virus that came off the Ruby Princess cruise ship or something like that? In other words, you would be able to track it back to where it came from?
Yeah, exactly. So it doesn't, we're hopefully familiar with contact tracing, which is a very, very important part of epidemiology. And the sequencing will not replace the epidemiology, but it will help the epidemiology in cases where there's no obvious link between person A and person B. And so that becomes really important when we're down to a low number of cases and we really want to understand the transmission routes in order to affect action which will eliminate it.
James Hadfield, thanks for joining us on the Health Report.
My pleasure.
Dr. James Hadfield is a phylogeneticist at the Bedford Lab in Seattle, Washington State. Twin studies have long been a darling of scientific research. They're key to understanding how the environment affects someone because you can generally exclude genetic considerations if you compare identical twins to non-identical twins, because obviously identical twins have the same DNA. Now, Australia's largest twins database is turning its attention to coronavirus research. Professor John Hopper is the Director of Twins Research Australia, based at the University of Melbourne, and he joins me now. Welcome, John.
Hi, Norman.
So how many twins have you got in the database these days?
Well, we've got 40,000 pairs have registered with us. We've been going for 40 years. It's about 10% of all twins in Australia, and we've got email addresses for a substantial proportion.
And those, as I said, are both identical and non-identical, so you can compare the two.
And opposite sex twins, which are very important for looking at sex differences.
So what are you, and just briefly before we get into it, so people really follow what I'd said rather briefly, what you're trying to identify here is the genetic contribution versus the environmental contribution to various aspects of life.
It's both studying, it's getting a handle on genetics playing a role, but it's also, as you nicely explained, it's also a tremendous way of getting a handle on the environment lifestyle while controlling for genetics. And putting it all together, it's not a competition of genes versus environment. Genes and environment combine to produce risk for diseases and outcomes. So
what do you, I mean, it's slightly mind-boggling as to what you think you can do in the SARS-CoV-2 or the COVID-19 pandemic. What are you aiming to do?
Well, first of all, we want to make use of the fact that, number one, twin and twin family designs are very powerful. Number two, we have a volunteer registry willing to consider participating in studies. And we have the ability to do research in real time very rapidly. It's taken us 2 weeks to get this study off the ground, and we're going to build on it as we go on. And we have a group of people who we know we can approach, we hope to approach them monthly to try and track what's happening to them, especially over the last year and beyond that. And we also have a lot of previous data from the twin studies to bring to bear about the history of the twins. So you're right, it's mind-boggling all the possible designs and ways this data can be used.
So essentially you've got if you like, an emergency group of twins that you can refer to who are willing to, at the drop of a hat, be part of a study.
Yes, and it's not just a study of twins for the sake of twins. Twins are just like everybody else, but they put a magnifying glass on what it is to be human. In particular, we haven't yet moved to the parents of twins. That's our next step. But it's hard enough bringing up twins without having to bring it up into the current situation. So it's putting the magnifying glass on not just the physical and mental and other issues that are involved, but the social issues, the economic issues. So that's what we're interested in, the whole gamut of how this pandemic might play out.
So what are you looking at in particular? Because you can't just go, well, presumably you can, you just go trawling and hope that the trawling net picks up something, but I assume that it's directed. I mean, what are you asking of them? What are you interviewing them about, or how, etc.?
Well, a very simple approach we're taking is just to ask the participants, the parents, the twins, and even hopefully the twins themselves, adolescent twins, to compare themselves with what they were a month before. So the first baseline questionnaire says, how are you compared to what you were before the restrictions came in? And then we follow this up every month so that we'll have a very rapid insight into how this pandemic is playing out within Australian families. In the fullness of time, of course, it would be wonderful to do genomic studies and to also identify twins who are in very different situations and see and interview them. So we're not just asking questions, we're leaving a box at the end for them to say what they think, what they are concerned about. So we're listening to the twins, and we have the potential to go back and do qualitative studies as well.
And are these twins of all ages?
Exactly, right across the whole spectrum. We have about 1,000 pairs per age up to about age 40, and then we have older twins as well. We have a special study of older Australian twins that has a lot of detailed information on twins that we'll also be involving in this research.
Right. And just finally, some of these twins will not be living together, so you can actually separate the effects of their environment as they've grown up and developed their own lives.
That's right. And we're matching them for age, sex, genetics, and then we're looking at those opportunistically, looking at those who have experiencing very different environments. For example, their working environments compared to living at home to being out there at the coalface facing being health workers, for example.
Well, John, I hope that you consider the health report not kindly when you've got some results to talk about.
Yes, and I'd be very interested in hearing from you and anyone else about issues that they think that and from the government for that matter, about the issues that they would like us to be asking about as we move forward. Okay,
we'll put a link to the email address that you will give us on the Health Report's website. Thanks for joining us.
Great, thank you very much.
Professor John Hopper is Director of Twins Research Australia and is based at the University of Melbourne. Substantial packages of money appear to have been made available to low-income countries to help them deal with the COVID-19 pandemic, and they're going to suffer the burden of this disease as time goes on, no question about that. Central to the fast deployment of this funding are the World Bank and the International Monetary Fund, the IMF. However, an editorial in The Lancet a few days ago sounded a warning that there's potential for these organisations to do considerable harm to fragile health systems. One of the authors was Alexander Kentikalinis, who is a political scientist at Bocconi University in Italy. Welcome to the Health Report, Alexander.
Hello, and thanks for having me.
What's the problem?
So, as you clearly stated in your introduction, this global health crisis that we're going through also has global economic dimensions. And in this manifestation of the crisis is where organizations like the International Monetary Fund or the World Bank or regional development banks come into play as the world's financial firefighters, so to speak, that have a mandate to help countries weather storms like this one. But what we have seen in the past is that often the advice of these organizations was misguided and actually deepened crisis. We can think of cases like Argentina or indeed even Greece, where the advice of organizations like the IMF did not help them to maintain a better financial footing. And in the early phases of the COVID-19 crisis and the global policy response to it, we saw signs from the World Bank, for example, that they would only provide support to countries that are willing to introduce the type of free market reforms that the organization has advocated in the past. So trade liberalization or deregulation of economic activity. Arguably now is not the time for these types of policies if they were ever appropriate. But
so what you're saying is it sounds like blackmail. Is really what you're saying is if you want to do this, you've got to actually abide by our policies.
Yes, this is exactly how the World Bank initially responded. David Malpass, its president, who is a Trump appointee, made that point very explicitly. Since then, they have backtracked a little bit. And it's still to be decided exactly what modes of financial support these institutions will offer. But the terms of their support is one key issue. And as I said, they have backtracked on these initial more problematic statements. But the other point has to do with the scale of the support. And what we see is that the International Monetary Fund has committed in principle has committed about $1 trillion US dollars. And the World Bank has said that they might make up to $160 billion available, although it's unclear. And this amount of money, while it is helpful, it falls far short of the projections of the amount of resources that will be needed, according to the research of the IMF itself. Its managing director said they need 2.5 trillion.
And the capital outflow has been the biggest in history from emerging countries, $83 billion in a very short space of time.
Exactly. And since then now it has reached about $100 billion. So countries, low and middle income countries, have to devote attention to defending their currencies as well as fighting the COVID-19 crisis. And this is exactly where the IMF could step in and help countries handle the situation, for example, through imposing short-term capital controls in order to stem this massive capital outflows that is destabilizing the economies of these countries until the global monetary system has stabilized a little bit.
And the balance between, I mean, if you don't, as we've said many times on the program, if you don't solve the health problem, you're not going to solve the economic crisis. What's the balance of investment here between health and the economy? Is it in the right direction?
So thus far, the vast majority of the money that has been committed by these types of multilateral lenders has been to support or is intended to support economic activity. There will need to be some shifting of the balance more in terms of supporting health systems more directly, and especially public health systems. And here we see some, again, problematic initial responses from the World Bank that wants to channel a lot of its support through its private sector lending arm, including for the support of private health infrastructures. Arguably, now is the time to invest in public healthcare systems, including health sector workforce, that can deliver better targeted interventions within low and middle income countries in order to handle the spread of this deadly virus.
So while countries like Australia, by and large, Canada and others who have universal healthcare systems recognise that the market doesn't operate here, they're proposing privatisation of health services and other things which we wouldn't accept in a country like Australia or Canada or Britain or other richer countries.
Exactly. That is what these organizations have advocated for many years already. Arguably now we are starting to see the costs of these deregulated, privatized healthcare systems and the adverse effects of past policies. Arguably now is the time for these organizations to reform their policies and revisit their outlook towards the appropriate allocation of public and private sector within healthcare. Outbreaks emphasize the need for good public sector programs.
We've only got a few seconds left. These criticisms of the IMF and the bank are not new. How tractable are they to this sort of criticism and responding?
Well, they're somewhat open to criticism, but it again points to the limitations of multilateral organizations altogether. So, for example, we see that the US is blocking extra funds to become available for the IMF, or indeed is blocking financial assistance to countries that it doesn't like Iran or Venezuela. So ultimately, these are failures of international organizations, but they're also failures of the countries that are behind them. So now is arguably the time for a broader rethink.
Alexander, thanks for joining us.
Thanks for having me.
Alexander Kentikalinis is in the Department of Political Economy and Sociology at Bocconi University in Italy. I'm Norman Swan. This has been The Health Report. See you next week.
You've been listening to an ABC podcast.